Okay, so welcome. This is the morning tutorial. We're going to go over GDB. This is a piece of software that is used to debug a program. So the basic idea is that if you have a program that you want to see how it's running, that you can step into it and see how the execution is working. So the values that are instantiated into the variables, and how the code is how the program moves through the code. So what we're going to do here is it's a way to get you to practice using GDB and play with it some and show you some of the functionalities. So I have some exercises to go through it, but I hope that this will get you started. And then as you are making more complicated programs, it's a way that you can figure out what's going on in code that you haven't written or code that you have written. If your first thought is, well, let me put in a bunch of print statements and see what the values are, this often works for very small programs, but as you can see, it takes a while to compile. So if you use debugging, you don't have to recompile with different print statements when you want to test something different. So it's a far step up from that style of trying to figure out what your program is doing. Okay, so to run GDB with Rosetta, or with C++ in general, you have to use this -G flag. And to do that, you can compile with either in mode debug, and this adds debug symbols. It also doesn't do the optimization. So if you do want it to be optimized and have debug symbols, you can use the release debug mode. In release mode, optimizations can sometimes move things around or make it so the source code doesn't quite match up with the execution. So unless it's running too slow, you'll probably have more fidelity in matching your source code to the actual execution in debug mode. And you probably don't have release debug mode already compiled. So for this, using the debug mode is fine. But if you're trying to debug something that takes, say, a half hour to run in debug mode, if it's going to run 10 times slower, then it could be very inconvenient to try to run it through debug mode. But in general, if you can narrow it down to a smaller test case and look at just what the problem is going on, then debug mode shouldn't be too bad. Okay, so if you wanted to run GDB from the command line, you type GDB in the path name to the executable, and you open up a program, the GDB, and you can change the working directory and run the program with the arguments. So the arguments will, as if you had passed the arguments in on the command line. For this exercise, I'm going to take the opportunity to try to encourage you to use Emacs to do debugging with GDB. I think this is one of the real great reasons to use Emacs. It allows you to navigate the source code and the execution sort of in the same environment. So you can set breakpoints and then stop at the breakpoints, or and look through the code. It's possible to do it on the command line, but if you have, we're going to try to do it through Emacs for this. Okay, so the basic idea of GDB is that you can run a program, and then if you stop it with, say, Control-C, or somehow you can pause the program with running into a breakpoint, then you can step through the execution of the program. So to step to the next statement, you type next, and this will, in the current function or in the current level, that you'll step through the lines of the source code, executing each line. If you get to a function call and you type next, it will just go over the function call and just put the value, the finished product of the function, as if it had finished. If you want to step into the function, then you use the step function, and this goes into the function and starts executing through that. So if you do step, it will step deeper and deeper into the stack, deeper and deeper into more and more function calls. And then once it's finished the function, and then it will return back out of the stack. So at any particular time, there's this idea of a stack trace, which is all the functions that are currently haven't finished yet. So if you type stack trace at the command line, then this prints all of the stack frames that are currently below you or above you. And it's possible to navigate up and down the stack. So the execution is still at the lowest level, but you can go up and see what was going on at a higher level say if you pause in the middle of a program, you're deep down into some vector operation, you can get back up and say, okay, well, I'm at this stage of my protocol. So to another one that's useful is finish, which will finish to the end of the function and then bring you back up to the next level. So there are a bunch more functions and things that can be done with GDB, but this is just the basics to get going. So if you want to no longer step, but then just run it normally, if you type continue, then it will run as if it continued to run. If it's too much to type all these variables, then it's the minimum unique subset first part prefix of the term will do it. So you can type S and N and F and B and C and R. Okay. So if you haven't used Emacs, it's a command line program, and open it up. Most of the commands to do things in Emacs, besides just simply typing characters, rely on using the control key or the meta key. And this is from the old school keyboards, which nobody has. So at least on my keyboard, if you hit the escape key, that's like holding down the meta key. So if you hit escape and then let go and then hit another key, that's like hitting the M. So if you look in documentation, you'll see this notation of M-key, and that means hit the escape and then hit the key. So like for instance, if you want to run GDB from inside Emacs, you do MX, which is you hit the escape, and then you hit the X, and then you hit return, and then it brings you up a little command down at the bottom of the screen, and you type in GDB and return, and now it's you're running GDB with inside of Emacs. If you want to run the shell with inside of Emacs, this is predominantly how I run the shell, so that way I can go back and forth between programs or the text files and running code. I can copy and paste between the command line and back to the, say, an editor. Then you can do the same thing with just running the shell application. To do the C, it's hold down the control key and hit the X, for instance. Or if you do want to save, so it's control C, control X. And there's a variety of commands off this. One concept that may be a little unfamiliar if you first open Emacs is there's this idea of a buffer. And this, you can think of Emacs as sort of like a window manager, where you have windows of different applications, and some of them can be tiled on top of the others, or they can be next to each other. Since it's just in ASCII, it doesn't have drop shadows, and you can't sort of see the corners of things. But what you can do is have buffers that are open but hidden and not particularly visible. Another concept is a frame, and this is like a window. So you can have a buffer be open in multiple frames, or have multiple frames open, and you can switch between them. I know Vim has this idea of having multiple panes open, and you can move between them. I predominantly use multiple frames, generally 3 or 4 at once, and then I switch between them. So I'll have the shell open, and then maybe a file open, or maybe 2 files open, or if I'm trying to look at a reference, I'll go back and forth between them. So I find this is a great way to program. GDB is Emacs is available on lots of different computers. So I SSH into my fast computer in our lab and do all my compilation and programming there. And that way, if my computer dies or I run out of batteries, then I haven't lost anything. And if I want to run it on the server, I can just SSH into the server and run it there, and GDB is working, and it's all in the same environment. So I know there's quite a few nice things with Xcode and Sublime Text and things, but running things through a command line editor does have a significant advantages that you can access it from many places. Okay, so that's the pitch for Emacs. Here are some common commands just that you'll probably find helpful if you want to try to do this lab. If you are typing some commands and you get stuck, you hit too many weird characters, Control G is like the cancel and any other things. I'm not sure why it's Control G, but that's what it is. So to open a file is Control XF. To save is Control XS. To close a file is Control X and then the K. And to close Emacs is Control X and then Control C. So to split, you can split vertically with Control X2, and you can split horizontally with Control X3. If you want to cycle to the other frame, it's Control XO. To close a frame, it's Control X0. and then to switch a buffer into the current frame that you are, it's Control-XB, and then you start typing the name of the buffer, and then it opens up. If you just Google for Emacs reference cards or tutorials, there's a variety of different descriptions. I, for instance, haven't shown you how to copy and paste, which is a little funky in Emacs, but hopefully you won't need to do that too much right now. And I hope that, that if you get more into it, you'll find it useful. There is a surprising amount of stuff that's been written about Emacs. I'm discovering new things every day, which is probably not good because it's if I've been using it a while and there's still stuff I don't understand, then it's probably complex. But in any sense, I found it useful. I know that other people found other editors useful. But, these slides I hope I shared with you, so you can find this while you're doing the tutorial. Okay, so to set a breakpoint in Emacs, so once you're running GDB, you navigate to the line of the file, and then its control space will set the breakpoint. Okay, so that is all I want to say about this. Please open up the tutorial lab and go through it. The idea is to be able to navigate through a simple program and practice using the different commands of GDB. Once you've done a very simple program, there's looking at integration tests are good programs to run through GDB because they're small and they run quickly. So there's a couple of examples of how to run through the fixed BB one just to get started. And then there's some longer running integration tests which you can use to sort of explore how they work or why they're taking a while. Okay, so you have questions? Okay, great, thanks.